In this example, we are going to graph the polar equation r equals 4 sine of 2 theta. Now, in order to do this, we are still going to create a t-table for values of theta and r. However, I am not going to plug in the typical values I would for theta of 0, pi halves, pi, 3 pi halves, and 2 pi. Instead, I'm going to take those typical values and I'm going to adjust them to make them a little bit more appropriate for this particular problem. The way that I'm going to adjust them is that I'm going to look at my equation 4 sine of 2 theta and particularly focus on that value that is multiplying theta. 2. I will take my 5 original values and I'm going to then divide each of them by 2. What this will do is it'll give me more appropriate values to work with in terms of theta for this equation. So, 0 divided by 2 is still 0, so I'm still going to be using 0 radians. Pi halves divided by 2 is pi halves times 1/2, or pi over 4. Pi divided by 2 is just pi over 2. 3 pi over 2 divided by 2 is 3 pi over 2 times 1/2, or 3 pi over 4. And lastly, 2 pi divided by 2 is simply pi. These are the values that I'm going to work with in terms of theta for this particular equation. It's recommended to always do this if you ever see anything multiplying theta. This will really help you get an idea of what is happening with these graphs. So, let's do this. Plugging in values of theta. 4 times sine of 2 times 0. Well, sine of 0 overall there is just going to be 0, meaning our final answer there is 0. If I plug in pi over 4, sine of 2 times pi over 4, well, 2 times sine of pi over 4 is just pi over 2, which makes that nice and easy to calculate. 4 times sine of pi over 2 is positive 1, which gives me positive 4 overall. If I plug in pi halves, I will get 4 times sine of 2 times pi over 2. 2 times pi over 2 is pi, and sine of pi is just 0. What we have essentially done here is that we've adjusted our theta values so that the calculations here come out to be nice and convenient. 4 times 0, 4 times 1, 4 times 0. We're going to see a very familiar pattern here based on what we know about sine, particularly if you think about a sine wave on a Cartesian plane. But if I continue with this, 4 times sine of 2 times 3 pi over 4. Well, 2 times 3 pi over 4 is 3 pi over 2, and sine of 3 pi over 2 is negative 1, will give me negative 4 overall. And lastly, 4 times sine of 2 times pi, which is just 2 pi. Sine of 2 pi is 0. So we're going to get another 0 here. So again, that nice pattern has continued. 0, 1, 0, negative 1, 0. This is what would happen if we continue to plug in theta values in this manner. So, let's graph these points. Starting with my first pair. I have 0 and 0. Well, 0 radians and 0 as a radius puts us right at the pole. So, rotate 0 radians and walk a distance of 0. My next point, however, is at pi over 4 and 4. That means face towards pi over 4, which is approximately in this direction, and walk a distance of 4 in that direction. Puts us around here. That means as I rotate counterclockwise, my radius is going to get progressively larger, so it's going to curve out to that point. With my next pair of points, I have pi halves and 2. That means face towards pi over 2. And sorry, my radius is 0, which means walk a distance of 0, or return back to the pole. So as I continue to rotate counterclockwise from here, my radius gets progressively smaller, which returns me back to the pole. So it seems like I've formed some sort of a loop here. If I continue graphing with 3 pi over 4 and a radius of -4, that means face towards 3 pi over 4, which is in this direction, and then walk a distance of -4. That's actually going to put us back 4 places, so that's going to put us over here in what we would consider in the Cartesian plane as quadrant 4. So from my pole, my radius is going to get increasingly negative. I'm going to curve out to this point. And with our last pair, we have pi and 0. That will mean face towards pi and walk a distance of 0 radius. That means that we are returning right back to the pole again. So we curved out and back in, and then out, and then back in again. But this is not the entire graph. If we wanted to get more points for this graph, I would recommend to continue in this pattern for theta. So the next pair would be plug in 5 pi over 4 to get r, then plug in 3 pi over 2, and then plug in 7 pi over 4, and keep going until you get this enclosed figure. However, what I'm going to do here is I'm going to use concepts of symmetry. And specifically, I'm going to reflect this over what I would consider the y-axis on the Cartesian plane. The rest of this graph, after I curve back in towards the pole here, I am then going to curve back out towards this point here and back in. And then out one more time up to this point in what would have been quadrant 2 of the Cartesian plane. Back in towards the pole. And that would now continue my loop. Then I would curve back out again and back in and start following through what I've already traced. This would be the graph of the function r equals 4 sine of 2 theta, which has a special name. This is called a rose.